Insertion sort is an algorithm that works on an array of elements that need to be sorted. The algorithm works by taking unsorted elements in an array and place them in the correct position in the sorted part of the array. There are basically three main steps. We iterate from the first unsorted elements to the last element of the array every time we compare the current element to its predecessor. When the condition is not met, then we move the rest of the element one position up to create space for the swapped elements. In average, we will have to perform comparison and swap operations, so the big O notation will be quadratic. The complexity class for this algorithm is P, since it can be solved in a polynomial time by a deterministic Turing machine. The traveling salesman problem is a challenge of finding the shortest route, visiting a group of different locations, and returning to the starting point. The solution is done by in factorial time. So the big O notation is On factorial, because if we consider all possibilities depending on the number of towns and remove the duplicate roads in reverse order, we have like 4 town, 12 possibility, 5, 60 possibility, 6 town, 360 possibilities. The complexity of the class is NP hard because first we can say we can solve in check in polynomial time that if each city was visited, but we cannot guarantee in polynomial time that the shorter route is the current solution that we have. So it's a NP hard problem. Finding the sum of values in a 3D array. The problem is to find the sum of all the values in 3D array. The algorithm will work by iterating over each array and compute the sum. The runtime will be cubic since we will be performing the same operation 3 times and the 3 arrays have the same length. The complexity class will be NP since the solution could be proved in polynomial time. Radix sort works by sorting each digit from least significant digits to most significant digits. So for example, in base 10, Radix sort will sort by digits in the ones place first, then the tens place, and so on. And Radix sort use counting sort as a subroutine. This means that if we have, for example, a 3-digit number in base 10, counting sort will be called for this to sort the ones place, then it will be called to count the tens place, and finally the hundreds place. The running time for big O notation is O and K, kind of linear. The time complexity comes from the fact that we are calling counting sort one time for each digit in the input numbers, and counting sort himself has a complexity that is linear. Radix sort is a the complexity class for Radix sort is P, since as insert sort it also can be proved in polynomial time. Brute force password cracking is a process of guessing password by using every combination of given characters depending on the length of the password. The running time will be exponential since it is solved by brute force using exponential, and n is the length of the length of the password. The complexity class will be NP complete since we are using a password checker, which is a Oracle solution, and the solution is reached by brute force.